All right, so just to look at the next 3 weeks ahead, today's basically over, so we have 13 days until spring break. Your test over this unit is going to be in 2 weeks on not next Tuesday, but the next Tuesday. Originally, we had it the Friday before spring break, but I said, who wants to test on a Friday before spring break? Not y'all. Who wants to grade over spring break? Not me. So, in conclusion, we took this right here, what's on the 6th and the 7th, off of the test and moved the test up. So, we are still going to be responsible for knowing what's on the 6th and the 7th. It's just not going to be tested on. You have SAT on the 5th. Are you going to be taking SAT during this class? No. We're going to be sitting and chilling. Unless you miss the test, you'll be taking a test. But if you choose not to show up that day, just know if you're not in here, you'll be marked absent. Take that into consideration about your absences. What do you notice about this week? One homework this Friday. We're actually going to take this Thursday to do a homework day, so that'll be nice. And then no quizzes this week, so that's nice compared to last week and all that craziness. This week's a little bit chiller. You will have 2 quizzes next week, 2 homeworks, and then your test. Any questions? Is it over? No. So today and tomorrow are going to be a lot of notes. I know it's going to be boring. I know you're going to want to put your head down a little bit. Resist the urge. Please. I don't love it when you have your heads and everything put down. Not my favorite moment. All right. We're just going to get into the notes so we can maybe finish a few minutes early. Sound good? Did everybody grab a highlighter when they walked in? No, I'll pass them out. Y'all don't need them just yet. All right, so first thing we're going to talk about is this whole unit is about polynomials. So a polynomial is a power function of degree n. Oh, a power function of degree n is a function of the form, can y'all please box this, f of x equals a times x to the n. And for these first 2 sections, we are going to do if a equals 1, meaning there's no visible coefficient in front of x. So I have f of x equals x to the 3rd. I'm talking. F of x equals x to the 5th. What do you notice about these things right here? Uneven is they're odd. So if I have x to the 7th, x to the 9th, x to the 11th, all of those functions, if you have nothing else but just that, are going to look like this. What do all of these look like? The cubic function. Do y'all agree with that? Okay. What type of symmetry does this have? Odd. What does odd mean? It is symmetric to the origin. If you don't know that, write that down. What is my, and can y'all add arrows? The computer model that we use doesn't have an arrow function because it was calculator. What is the domain of this function? All real numbers. Is your phone put away? If I catch you on it, I'm taking it up. What is the range of this function? All real numbers. And what 3 points are on this graph no matter what the exponent is? 0, 0 is one of them, because 0 to any power is 0. What else? 1, 1. Do you agree 1 to any power is 1? And negative 1 to any power is, any odd power is negative 1. So those 3 points are going to be on any odd graph that looks like this. Now, this is new. So I need y'all to look up and then you will write. Kinley, if you can shut your computer, please. My n behavior, do you agree this ends up going up to the right and down to the left? This is called n behavior. We already learned about n behavior last unit, right? However, it was not on your test. It will be on these quizzes and these tests. So the way I would like you to write n behavior is as a limit. Watch me and then write it. You are going to write the limit as x approaches negative infinity of f of x equals, watch please, and the limit as x approaches positive infinity of f of x equals. Now you can write these. While you're writing them, limit should be up top. The x with the arrow should be right underneath it. And then f of x is the whole thing. Don't put f of x underneath limit. What this is asking is what's happening as it's going to the left, what's happening as it's going to the right. So what is happening to my graph as x is approaching negative infinity? It's going down. So what is it approaching? Negative infinity. What is happening? What's the limit as x approaches positive infinity? As it's going to the right. What's it doing? Going up. It's going to infinity. Now, what happens to my graph as my exponent gets bigger? What's happening? What's happening? It does. It's kind of getting flatter, although it's not necessarily flat, but what's happening up here? It's getting steeper. So what I would like you to also write down here is as the degree increases, the graph gets steeper. Now I want you to compare the graphs of x squared and x to the 6. Fill in 1 through 4 to the best of your ability. Go. If you want to use your own highlighter, you're more than welcome to. What type of symmetry does this have? Even symmetry. Which means what? It's symmetric about the y-axis or to the y-axis. What's my domain? Oh, draw arrows on these, please. What is my range? So you could have either written 0 with a bracket to infinity with the parentheses, or what else could you have written? Ooh, be careful. Range. Y such that y is greater than or equal to 0. What points are going to be on this graph no matter what the exponent is? 0, 0, 1, 1. Again, any 0 to any power 0, 1 to any power is 1. And then negative 1 to any even power is 1. And this is going to end up going the same direction. So this is going to be my limit as x approaches negative infinity of f of x. And my limit as x approaches positive infinity of f of x. Both of these end behaviors are doing what? Increasing, going up. So they are infinity. Please write that down. Check yourself. And we're about to just highlight. I'm going to talk and you're just going to highlight. Y'all ready? Okay. What happens to the graph of f of x if a does not equal 0? So everybody, we're looking at this a right here. If it does not equal 0, then the absolute value of a determines the width of the graph. Again, what I'm about to read you is transformations we learned last test. You should know most of this. But what happens if a is the absolute value of a is greater than 0? I mean greater than 1? It's going to stretch vertically, and therefore it's narrower. What happens if a is between 0 and 1? It is going to compress vertically or get wider. I like to say fractions make you fat, or at least fractions less than 1. Okay. Next, a power function is also a type of monomial. What does mono mean? All right, these are the most basic polynomial functions. It only has one term. All right, so it's monomial. The sums and difference of monomials functions form polynomial functions. So you take a bunch of different terms, add them together, that's a polynomial. A polynomial function of n degrees, highlight that please, is a function of the form, and then it gives us this crazy thing right here. I'm not going to have you worry about that. Once I put numbers, it'll make more sense. But basically, these are numbers with x's with exponents. A's are real numbers. N's are non-negative integers. Those are your exponents. That's what you really need to know. N is the exponent, and then A is the number in front. But y'all already know that from here. The leading coefficient of a polynomial function is the coefficient of the variable with the greatest exponent. So let's highlight the leading coefficient of a polynomial function has the greatest exponent. Polynomial functions are defined and continuous for all real numbers, meaning you are not going to pick up your pencil. They have smooth, rounded turns. Make sure you actually draw round turns, not pointy turns. And graphs of polynomial functions do not break, have holes, gaps, or sharp corners. All right. Next, I would like you to highlight this graphing form of the function. The graph of this, what's the H going to do? We already talked about A. What about H? Shifts horizontally. And what is K going to do? Shift vertically. Please highlight those. And then what if A is less than 0? What is that going to mean? If you have a negative A, what is it going to do? Reflect across the x-axis. So please highlight those different things. I tried to highlight the keywords so you can just kind of skim through as you're studying the highlighted words. Turn over when you're ready. Next. Now we are going to, you're going to have to do this on your quiz next Monday, is graph these different transformations. So I'm going to do A and C with you. For A, what is my parent function here? Y equals x to the 4th. And so is this even or odd? Even. If it is even, what is it going to look like? Going to look like a parabola, right? And what's the transformation here? Left 2 units. Please write this down. I'm about to write left down because I said write it down. Left 2. Jaden, you with me? All right. So be careful. The instructions, every year people get this wrong because they don't read the instructions. It tells you to label 3 points. So if I go left 2, where is my vertex going to be at? Negative 2, 0 is one of my points. Where's another point going to be at? Negative 1, 1. You see how I'm labeling that right there? I need to write a tick on the y-axis because I labeled a point there. So negative 1, 1. And what's another point going to be? Negative 3, 1. So again, I need a tick on my x-axis to show that that's negative 3, 1. And then please graph your parabola. Make sure it is not pointy. I'm going to go down and do the next one. What is my parent function for C? What's the parent function for C? Y equals x to the 5th. Even or odd? Odd. So what do we know about this one? What's it going to look like? It's going to look like a cubic function. What are my transformations here? Up 1, because it's a positive 1. And what else? It's going to be a reflection across what? I spelled across wrong. Across the x-axis. Goodness gracious. So normally it starts at 0, 0. That reflected isn't going to do anything. But then I got to do what? Go up 1. So 0, 1 is one of my points. The next point normally is going to be at 1, 1. If I reflect it across the x-axis and go up 1, where do I end up at? 1, 0. And then normally I'm at negative 1, negative 1. Reflected across the x-axis, go up 1. Where am I at here? I'm at negative 1, 2. And then graph your function and draw arrows. What questions do I have? You do B and D. Go. Look up when you are done to check yourself. If I were in the grading mood, why would I get points off for this one? I did not label my points. Please do not forget to label your points. Do I have any questions about B? Did we all get that right? Did I get it right? All right, D. If I were grading this, why would you get points off? Where? On the x-axis. You have no tick marks indicating that that's at 1. Please make sure you have tick marks anywhere you have a point to show that location. Do I have any questions? All right, you can put down your pencils and get your highlighter. We're going to highlight some more. Did I go too fast? See, a couple people writing. Oh, wait a minute. Okay. The leading term test. Your leading term test uses powers of the uses the power and coefficients of this term to determine end behavior. So what I would like you to do is please highlight this word odd degree, or these words odd degree. All right, if it's odd, your leading term is odd, then your end behavior will be going different directions. So actually maybe write that down. They will go different directions. So your end behaviors will be different answers. If A is greater than 0, it will end in positive infinity. And if A is less than 0 or negative, it will end in negative infinity. So if A is greater than 0, A is positive, it's going to end positive. If A is less than 0, it's negative, it'll end negative. Then highlight even degree. Even degree looks like a parabola, and they will go the same direction. So if A is greater than 0, it will start and end positive. If A is less than 0, it will start and end negative. Please highlight and write that down. And highlight those arrows. If it's positive, they'll both go up. If it's negative, they'll both go down. All right, turning over. So let's apply the leading term test to find the end behavior. By the way, for your questions like this on your quiz, I will be expecting you to prove it and then do the end behavior. So everything I'm writing down, I will expect you to have. For instance, number 1, what is my leading term here? 3x to the 4th. Everybody highlight or box it. My A is what? 3. Is that positive or negative? Positive. So that's greater than 0. So it's going to end going up. Do y'all agree with that? Because it's greater than 0, it's positive. My n, what's my exponent? 4, even or odd? Therefore, it is even, which means they're going to go the same direction. So they're both going to go up. And now I can write my end behavior. The limit as x approaches negative infinity of f of x equals the limit as x approaches positive infinity of f of x equals. What is happening as it goes to the left? It's positive infinity. What's happening as it goes to the right? They're the same. They should be the same answer. And that is how you do end behavior. Figure out if it's positive or negative. Figure out if it's even or odd. Be careful with B. What does B say? Or what's different about B? Not say. What is different? Ooh. The bigger power is in the middle. Don't get tricked. What's my leading coefficient here? Negative 2x to the 7th. So just be careful. What does my A equal? Negative 2. Negative 2 is less than 0. It's going to end up going down. What's my N? 7, which is odd. Same direction or different directions? Different directions. So this is what your end behavior is going to look like. I want y'all to give me the limits. Go. What did y'all get? As x approaches negative infinity, what happens to f of x? Positive infinity. It's going up. As it goes to the left, it's going up. What about as x approaches positive infinity? Negative infinity. There you go. Do I have any questions about the leading term test or how to determine end behavior? No? We're super excited? Super invigorating stuff? Do we miss the unit circle? At least how interesting it was? No? We can go over it if y'all want. All right. Get your highlighters out. We're going to highlight for a little bit real quick. We're almost done. We're just finishing this page. We don't have any more after this page. All right. Turning points. Turning points indicate where the graph of a function changes from increasing to decreasing or vice versa. They create a maxima or a minima. I also call this a maximum or a minimum. Those are where your turning points are. So if my turning point looks like this, goes from decreasing to increasing, what is that going to be? What is that when it goes from increasing to decreasing? A minimum. And if it goes from increasing to decreasing, what's that? A maximum. And then we also have zeros. What are zeros? X-intercepts. So zeros are x-intercepts. We're going to call those C. So C is a 0 of f if f of x equals 0 there. And also just know we can write it as parentheses x minus c as the factor. What I just highlighted, that's nothing new to y'all. Do y'all agree with that? What's new is how to find the 0 and the turning points. So a polynomial function f of degree n, or the degree that's greater than or equal to 1, has n distinct real zeros and n minus 1 turning points. So, what that means is if you can look at the leading term, you can automatically know how many zeros and how many turning points there are just by looking at it. So, what I want you to do real quick on all example 3, 4, and 5, can you just on this side write number of possible zeros, number of turning points. And I'm going to shorten that to TP after this because I don't want to write it all. So, number of possible zeros, number of TP. And on number 5, do that too, please. What is my leading term in my first problem? Anybody? X cubed. So, what does n equal here? 3. So what's the number of possible zeros? 3. What's the number of turning points? Subtract 1. The number of possible zeros is just n. The number of turning points is n minus 1. Do that for number 4 and number 5, please. Figure out your highest degree. What's my possible zeros for example 4? What's my number of turning points? Bam. That's it. That's not all we're going to do, but that's it for that. All right, last one. What is my leading term? What does n equal? So possible zeros, number of turning points. That will be a question on your test. It'll be a question people leave blank because they don't look back at this ever again. Look back at it. All right, we're not done. We're going to finish this real quick. The question for example 3 says state the number of possible real zeros and turning points. Check, check. Then determine the real zeros by factoring. How can I determine the real zeros of this? X cubed minus 5x squared plus 6x equals... What do zeros equal? 0. How do I factor this? Take out an x. Factor out an x. Oh my gosh, this is so easy. Don't get lazy on me right now. What factors of 6 add up to negative 5? Does that make sense? What are my real zeros? Be careful. What are my real zeros? Zero, 2, and 3. Why do we have to include 0? Because that x we factored out front. How many zeros are there? How many zeros did we say they were going to be? 3. Does that make sense? Number 4 is not as simple. Do you know how to factor this? Don't give up. You're not going to have one this difficult, but I do want you to see it. This can be factored by x squared and x squared. What factors of negative 4 add up to negative 3? Negative 4 and positive 1. But wait. Can I keep going? What is x squared minus 4? Do y'all agree that's a difference of 2 squares? X plus 2 and then I cannot do anything with the other one. So what are my real zeros? Negative 2 and 2. But how many zeros did we say there were going to be? We said there were going to be 4. But there are only 2. Why? I have this x squared plus 1. If I make it a 0, what happens? What is the square root of negative 1? You can't do it, but what is it? I. The other 0 that you don't see is non-real. So there are 4 zeros here. They're just not real. Today we're not doing that. We are going to get to that. We'll get to that. Let's see what day. That's like, oh, that's over here. We'll get to that like next week. For today, we're just doing real zeros. But I did want you to know that there are non-real zeros. All right, last thing I'm going to go over, and then we're done. Highlighter again, please. Is repeated zeros. If x minus c occurs more than once, then it is called a repeated zero. So what that will look like is if you have a factor, I'm going to make up a letter even though it's not here, and it has an exponent above it like this, an m. If there's an exponent on one of your factors, it's called a repeated zero. If that m is even, it will be tangent to the x-axis. And if it's odd, it will cross the x-axis. What does tangent to the x-axis mean? What does tangent mean? Touch it how many times? It means it touches it once. It does not go through it. So it is going to bounce. So if you have an even exponent, it will bounce there. We're going to talk all about this tomorrow, but I want to just quickly show you what that means. And let's factor this one. How do I factor example 5? What can I do first? Take out the negative, and what do they all have? X squared. What's that going to leave me with? X squared. What? Be careful, because I took out a negative. It's going to be plus x minus 2. Ooh, that second parentheses did not get a lot of room. And what factors of negative 2 add up to 1? Am I right? What are my real zeros here? What's that going to give me? It's still going to give me 0, but do you see how it has a squared with it? So it's going to be 0. It is repeated. And whenever something's repeated, we write multiplicity, and this is 2. So this has a multiplicity of 2. It has an exponent of 2 with that factor. And then what are my other zeros? Negative 2 and positive 1. We will finish this tomorrow. We just have, just the back page, just page 4 to do tomorrow. All right.